Hello, this is Mr. Kinyanola, and I'm going to show you how to solve a system of linear equations that looks like this. But before I show you how to do this, let's get this concept and let's see what's hidden under my piece of paper. What a whole wad of money. Where I have a dollar bill, not a lot of money, but just, let's see how much money I have exactly. I have a dollar bill, I have a quarter, another quarter makes 75 cents, 2 dimes, and a nickel makes 100 cents or a dollar. So it looks like this piece of paper right here, this dollar bill, is the same value as these coins right here. So because they're the same value, they're equal to each other. And because they're equal to each other, we could substitute them. If you gave me a dollar bill and said, Mr. Q, do you have change for a dollar? I would assume that you want change that adds up. The sum of all the coins I gave you is a dollar. So I could give you these coins, I'll take the dollar, and you wouldn't fight about it. Or you could give me these coins and say, Mr. Q, I don't want to carry change. Could I have a dollar bill? I said, sure. All right. They're of equal value. They look different. Here's the concept. They look different, but they're of equal value. Okay? And we could substitute them. The word substitute is when you take things of equal value and exchange them. So let's look at these two equations right here. We're going to look at an equation that has a variable by itself, this y. Think of this as the dollar bill. And it's equal to 5x plus 14. Think about this as the bunch of coins. If you want to write this down in your notebook and follow along, do it. Press pause and write it down, then press play again. And then we're going to look at this equation. Is there another y there? Yep. Excuse me. So we have the y's, and we know the y's because of this equation tells us the y's equal to 5x plus 14. From there, we can perform some substitution. So we're going to take this equation. I'm going to write negative x plus 4. Now we want only one variable, so this is the beauty of substitution. We're going to exchange this y for what it's equal to. And don't forget, every time we substitute, put parentheses. We're going to take the y and substitute it with what it's equal to, the 5x plus 14, and equals 18. Now these parentheses are so important because this 4 in the parentheses tells us to distribute the 4 to the 5x and the 14. Okay, if we don't want to forget to distribute the 4 to the 14, because then the 14 will feel left out. Why didn't you give me the 4? Okay, so let's distribute means multiply everything that's inside. So let's multiply 4 times 5x is 20x. 4 times 14, let's mental math this or use your calculator, is 56 equals 18. Wait, don't forget this negative x. Okay, we did all this work, but don't forget what's left over here. So bring that down, negative x. Now, when we see a variable with no number, no coefficient in front of it, there's always an invisible 1. Okay, so let's put that invisible 1. Now let's see if we can combine any like terms. Negative 1x plus 20x or 20x minus 1x is 19x plus 56 is equal to 18. We want all the numbers on one side and all the variables on the other side. So we're going to take this 56 and subtract it to the other side. So subtract 56, subtract 56, 18 minus 56. I don't trust my mental math on this one. Let's see. Let's type it in. Oh, I already have it in my calculator. 18 minus 56 is negative 38. Don't forget that negative. Negative 38. And these cancel out. 19x will bring that down. And when there's no operator in between, no plus, minus, multiply, or divide, the invisible operator is times. Timesies. And we want to get rid of this 19. The opposite of multiplication is division. So we're going to divide away that 19 from both sides. So x equals 19 goes into negative 38. Don't forget that negative right there. Okay, so a positive and negative make a negative. 19 goes into negative 38, negative 2 times. Okay, so always be careful about the negatives when we're doing these problems. All right, so but we're not done. We have two variables. So we're going to take this negative 2 and plug it into any one of these two equations. I'm going to plug it into this bottom equation because the y is all by itself. So I'm going to write y equals, and I'm going to substitute again. So x equals negative 2. So I'm going to substitute the negative 2 into the x plus 14. And we'll just do some math here, some arithmetic. 5 times negative 2 is negative 10 plus 14 equals y. Negative 10 plus 14 is, or 14 minus 10 is 4. So now we have both of our variables. So our answer as an ordered pair would be negative 2, comma, oops, almost wrote 14, 4. All right, there is our answer. How do we know that's our answer? How do we know that's our correct answer? We'll check it. Let's check this. Let's plug it into both equations. Now, the tricky thing is when we have negatives. Okay, I always see students, they do all this great work, but then they're negatives. They forget about them. So let's not forget about them. So let's plug it in. Substitute into this first equation, negative, parentheses, our x is negative 2, close parentheses, plus 4, and our y is 4 equals 18. Let's see if this really does check out. Okay, so if both sides equal 18, we're good. So negative times negative 2 is positive 4. Oh, sorry, not positive 4. Positive, oh, my multiplication is not correct. Is positive 2 plus 4 times 4 is 16 is equal to 18. 2 plus 16 is 18 equals 18. That works out for the first equation. Now let's plug it into the second equation. Substitute into the second equation. So our y is 4 equals 5 times negative 2 plus 14. So we're just substituting our x and y into here. And let's see if both sides equal 4. Okay, so 5 times negative 2 is negative 10 plus 14. Negative 10 plus 14, or 14 minus 10 is 4. Ha! Look at that. 4 equals 4. Both of these values, negative 2 and 4, work for both of the original equations. 4 is always equal to 4. 18 is always equal to 18. So yes, this is our answer. Negative 2, comma 4. All right, let's do another example. If you want to press pause, try this for yourself. Okay, and then press play and see if you got the correct answer. Then go for it. Or if you just want to follow along, just follow along. All right, so we have our y equals this, negative 5x minus 8. We have another y over here, so we can substitute. Look at all these negatives. Okay, so be extra cautious when there's negatives. We don't want to mess those up. We don't want to do all this beautiful work and then mess up on a negative. So we're going to take this equation, 6x minus 4, and we're going to substitute because y equals that, equals negative 5x minus 8. So substitute that into the y, equals 6. So I took this equation, 6x minus 4, and y equals negative 5x minus 8, and I brought down that 6. So the same thing, just like the example of $1 bill and all the quarters. We're putting all the coins, not just the quarters, but all the coins together that make a dollar bill for the $1 bill in there, substituting. Now we're going to distribute. Look at all these negatives. 2 negatives make a positive, so that would be positive 20x Again, two negatives make a positive, so that's positive 32 equals 6. And don't forget to bring down the 6x. All right. Now, 6x plus 20x would be 26x plus 32 equals 6. We want to get all of the variables on one side and all the numbers on the other side. So we have a variable here, no variables here. So we'll get rid of this number right here. Subtract the 32 from both sides. So we have 26x equals 6 minus 32. This is the bigger number with a negative. Okay, so our answer will be a negative 26. Okay, so we're taking positive 6 away from the negative 32s. We still have negative 26 left. Remember, when there's no operator, it's an invisible multiplication sign. The opposite of multiplication is division. We're going to divide both sides by 26. So x equals negative 1. Don't forget that negative. Okay. Now, zoom back out. We're going to find our y because we need both variables. So we'll take this negative 1 and then I'm going to substitute it into the first one since the y is by itself and we want to get y. So y is equal to negative 5 times negative 1 minus 8. Two negatives, look at all these negatives. Two negatives make a positive, which is positive 5 minus 8. 5 minus 8 is negative 3. And there is your answer. Our answers, negative 1, comma, negative 3. And if you want to check this x and y value, just substitute them back into both equations like I showed you in the first example and make sure they both work. All right, so I'll leave that up to you to do. Okay, I've checked my work in my head, and I'm pretty sure it works. Let's do another example. All right, here's the y. Y equals that. Here's a y. So we can substitute this in for the y. So if you want to press pause, try it on yourself. Try it for yourself. Then you can, or just follow along. Okay, so we're going to take this negative 7x plus 5. Don't forget to put the parentheses right there. We're going to substitute this negative 2x plus 13 equals negative 20. So exact same equation, exact same. I use that term loosely because this is the y. Okay, so it's the same value. It looks kind of different. It does look different. It's not just kind of. It looks different, but it's the same value because the y's are equal to each other. All right, we're going to distribute this 5. Distribute that there and there. 5 times negative 2x is negative 10x. Plus 5 times 13 is 65, I think. Okay, let me double check. 5 times 13. Yep. Okay. Equals negative 20. I'm going to bring down this negative 7x right there. And let's look at it. What terms can we combine? Do we have some x's that we can combine? Yep. Two negatives. Okay, so we're not multiplying, we're adding the negatives. Think about this. We have negative 7x's. We have negative 10x's. How many negative x's do we have total? Negative 7's plus a negative 10x will be a negative 17x. Plus 65 equals negative 20. I gave you a lot of examples with some negatives, so please, those are the problems that students tend to make mistakes on. So please be wary, please be cautious, please pay attention to the negatives. Okay, now we're going to bring all the numbers on the other side. So I'm going to subtract this 65 from both sides. A negative 20 and a negative 65. We have negative 20s here. We have negative 65s here. So that's a total of negative 85's there. Okay. And then we're going to bring down this negative 17x. All right, now let's zoom in. All right, so negatives and negatives, when you combine them, will give you a negative. All right, now multiplication, invisible multiplication. The opposite of multiplying is dividing. We're going to divide by negative 17. Look at that, all these negatives. Okay, I'm just going to make sure. I think it's 5, but I'm going to take... We know two negatives make a positive, so our answer will be a positive. So negative 85 divided by negative 17 is positive 5. There we go. There's our x. Now we'll take our x and substitute it back in. I like to substitute it in the first one just because that y is by itself. And that's our goal right now. Figure out what y is. So we'll take y equals negative 2 parentheses 5 plus 13. Because x equals 5, we could substitute it in there. And now let's do some arithmetic. Negative 2 times 5 is negative 10 plus 13 equals y. Negative 10 plus 13, or 13 minus 10, is 3. So our answer would be 5, 3. Now if we were to graph this, these two equations would meet at 5, 3. So if this equation said, hey, let's meet somewhere, to this equation, and this equation said, okay, let's meet somewhere, what would that address be? What would the coordinates be? They would meet up at 5, 3. Yeah, let's go get some ice cream at 5, 3. So that's it. If you don't believe me that this is the answer, then take these two numbers, plug them back in, substitute them, and make sure that they both equal each other, so that this side would equal this side, and this side would equal negative 20. All right, that's how you substitute with a system of linear equations when only one equation equals y. Have a great day.